Hello everyone. Today we are taking a closer look at our nearest star, the Sun, to understand its impacts on our lives. So let's get started. The Sun is not just important for our planet Earth, it's like a source of superpower in the solar system, holding everything in place with its strong gravity. Without the Sun, we wouldn't have daylight, warmth, or the beautiful blue sky. On Earth, we even use the sun's energy to generate electricity using solar panels that turns the sunlight into electricity. This is a clean and renewable energy source for powering our home electronic appliances. But have you ever wondered what's going on inside the sun? Let's find out. The sun is not just a giant burning ball in the sky, it's a massive, glowing, hot ball of plasma, which is a ionic state of matter similar to gas, but made up of electrically charged particles. The sun is not an average star when it comes to size and mass. The mass of sun is about 330,000 times that of Earth, and it's incredibly large, over 109 times the diameter of Earth. It's so big that more than 1 million Earths could fit inside the sun. The Sun is located in the Milky Way galaxy in a spiral arm called the Orion Spur. The Sun moves around the center of Milky Way, bringing along the planets, comets, asteroids, and other objects in our solar system. Also, the Sun rotates on its axis as it revolves around the galaxy. Since the Sun is not solid, it rotates at different rates at different latitudes. At equator, it takes about 25 Earth days for one rotation, while at the poles, it takes 35 Earth days. As a star, the Sun doesn't have any moons, but the planets and their moons revolve around the Sun. Now, let's understand how the Sun formed. The Sun was born about 4.6 billion years ago from a large spinning cloud of gas and dust called the solar nebula. Over the time, this cloud collapsed due to its own gravitational pull, spinning faster and flattened into a disk shape. Most of the material was pulled towards the center to form the Sun, which accounts for 99.8% of our solar system's mass. Much of the remaining material formed the planets and other objects. According to NASA, the Sun is made up of mostly hydrogen, roughly about 92%, and helium 8%, with a very small amount of heavier elements like carbon, nitrogen, oxygen, magnesium, silicon, and iron, making up just 0.1%. The Sun has different layers, each with distinct properties and behaviors. At the very center, there is core, incredibly hot at approximately 15 million degrees Celsius. This core is where thermonuclear fusion takes place, with hydrogen atoms colliding and fusing together to form helium. This process is also known as the hydrogen cycle. During this fusion process, tons of hydrogen converts into helium every second, releasing a huge amount of energy. This energy radiates outwards from the core and spreads across the entire solar system. A small fraction of this energy penetrates Earth's atmosphere, warming our planet and lighting up our days. Unfortunately, we can't just see inside the Sun because it's too bright and hot. However, scientists have figured out what's happening inside the Sun by studying it from a distance. After this, the energy from the core is carried into another layer called radiative zone by photons in the form of electromagnetic radiation, which bounces around randomly in the radiative zone. These photons taking about 170,000 years to travel from the core to the top of the convection zone. Moving outward in the convection zone, the temperature drops to below 2 million degrees Celsius. Here, large bubbles of hot plasma rise towards the photosphere, which is the bottom layer of the Sun's atmosphere. The photosphere is characterized by the bright bubbling granules of plasma and darker, cooler sunspots. Now, here is the interesting part. The sun doesn't end at the photosphere. Above it, there are two more layers that are much hotter and more energetic than the surface layer. These layers are chromosphere and the corona. The chromosphere is a thin layer of plasma that emits a reddish glow as superheated hydrogen burns off. However, we can only see this red rim during a total solar eclipse. At the other times, the chromosphere's light is usually too weak to be seen against the brighter photosphere. Lastly, there is the corona layer, which is the outermost layer of the Sun's atmosphere. Similar to the chromosphere, the Sun's corona can only be observed during a total solar eclipse, when the Moon passes in front of the Sun, creating white streamers or plumes of ionized gas that extends millions of kilometers into the space. The solar corona has a temperature of 2 million degrees Celsius, which is a much higher than the surface temperature. But we are still not sure why it is so hot. Because of this high temperature, most of the radiation emitted by the corona is in the form of ultraviolet and the X-ray wavelengths. The chromosphere and corona layers are crucial for understanding space weather activities such as solar flares, coronal mass ejection, solar winds, and solar radiation caused by the sun. But they are very difficult to observe from Earth. This is because they appear much dimmer than the photosphere and often get hidden by the sun's brightness. To see them clearly, we require special instruments that can either block or filter out most of the visible light coming from the photosphere. This is why the solar space programs and advanced instruments become essential. NASA and other space agencies continuously monitor the sun using various specialized spacecraft. These spacecraft look closely at the different parts of the sun, like its outer layer, inner core, and what's inside. Some of these spacecraft dedicated to studying the sun are named Parker Solar Probe, Solar Orbiter, SOHO, ACE, IRIS, WIND, HINOTE, Solar Dynamics Observatory, and STEREO. So there you have it. Our sun is more than just a giant ball in the sky. It's a massive star that shapes our world, and understanding the sun is important for our future. Thanks for watching, and remember to hit that like button and subscribe for more interesting videos.